2015, day 6. Signals and noise. Something is jamming your communications with Santa. Fortunately, your signal is only partially jammed, and protocol in situations like this is to switch to a simple repetition code to get the message through. The same message is sent repeatedly. You recorded the repeating message signal, your puzzle input, but the data seems quite corrupted, almost too badly to recover. Almost. All you need to do is figure out which character is most frequent for each position. For example, suppose you recorded the following message. The most common character in the first column is E. Oh, okay. In the second, A, and the third, S, and so on. Combining these characters returns the error-corrected message Easter. Okay, so that's our test data. Let's go here. Oops, wrong one. Let's go here. So day 6. Day 6. Oops, 6 and 6, and then we're going to add day 6 here. And then we go here. (2016-06) and do that. Run. Okay, good. What's next? So now we need to do, we have the test input. Is there any parsing we need to do? I don't think so. Let's say let test data equals vec bang, and we'll just paste, not paste that, we're going to paste this. Copy, paste. Okay, and then we'll just do this. At the beginning of each line, we'll just put a quote, double quote, and at the end of each line, we'll just say quote dot. Do we have to do a toString? I don't think so. Comma. And then we just close bracket, semi, and then reformat. Okay. So for now, for each entry, can we do it that way, or we can do it this way, right? We need to do is add up for each one of the columns what the most common letter is for that column. Well, I mean, we can use the same technique we used last time, right? Use standard collections hash map. And we can create a hash map for each one of the columns. We don't know how, I guess we do know how big it is, right? We can figure out how many to make. Let mute char list equals vec of, we'll just say vec new, because we're going to make a vector of hash maps for I in test data dot of 0.len char list dot push hash map new. Okay, and now for each entry in the test data, and then we can say for C in entry.chars, I comma C in entry chars enumerate, that's a usize and that's the char. We say star char list dot of I dot entry of C dot insert what was it? What did I do for it? Source being run AOC 20, I've already forgotten. AOC 2016-04. Oh, it's down here somewhere. If it's real. Or insert. That's it. Or insert. Insert 0 plus equals 1. And then we can just print that out. Println char list. And let's see what it comes up with. It builds, but I don't think that builds. Usize is not an iterator. Oh, in 0 dot dot. Yeah. So I have to do another clean. This is kind of frustrating. Cargo clean. All right, so this generated something. So for the first character position, T is 2, A is 1, N is 1, S is 2, R is 2, E is 3. So that's the most common. All right, so now we just need to look at the most common one. Let's just run that real quick. So all we need to do then for each one now is sort based on the value. So we can collect them the same way we did last time. Right? Negvorsa says insert C increment I. Is that what you meant by here? Here's increment I on C. I think that's what you meant. Hopefully, because that worked. So, okay. We need to go for each entry in the char list now. For CL in char list, we're gonna find out which one has the highest count. It's gonna be a little awkward. Let V equals vec. What was it? Char and I32. What is this type, by the way? It is I32. Okay. Because this one, I guess, defaults to an I32. So vec of char I32 is equal to char list of, no, CL dot iter collect. Nope, that doesn't work. Oh, because this needs to be a colon. I don't know why it shows bool when that happens. Okay, so that works. And then we say v.sort by AB, v.1.compare with a.1. And then the most common letter is going to be the first one in the vector. Println v of 0. V of 0 dot 0. Okay, let's see if that prints out Easter. E-A-S-T-E-R, Easter. Look at that. All right, so we just need to collect that into a string. I don't know why it took so long. That was very slow. Oh, to build it, I was doing this. I see. Okay. So let's do the usual let result equals to string. And all we need to do is now say result.push v of 0.0. And then this becomes results. And I failed. There, Easter. Okay, so now instead of test data, we're going to read in the actual data. Let input equals AOC lib read lines input slash 2016 06.text. Oh, we never got it. Oh, that'll be a good test of our error detection there, right? And an input of 0.len, and then this becomes input of 0. I mean, just input. Okay, that should fail because we don't have that file. So let's get that. Get input 2016 06. Oh, just 6. 624 lines. (2016) day 6 input. Let's take a look at it. Any second now. Okay, so they're not hugely long lines. It's just 8 characters long. But there's a bunch of them. Okay. I guess we can rerun. That was fast. It came up with that answer. Is that the right answer? Haha, look at that. Okay. Let's check with Clippy. Good. Git add source. Git commit -m 2016 day 6 part 1. My brain is almost fried, but let's try part 2 because I don't want to leave that part hanging. Let's see what this says. Of course, that would be the message if you hadn't agreed to use a modified repetition code instead. In this modified code, the sender instead transmits what looked like random data, but for each character, the character they actually want to send is slightly less likely than the others. Even after signal jamming noise, you can look at the letter distributions in each column and choose the least common. Oh, that's cute. It works out as Advent. So Easter versus Advent. We can do that with the test data. So for part 2, oh, I guess we don't have to worry about it. So what we did here was we built up these lists, and then here's where we cared about it, right? So we can do this in the parse section. In fact, that's where it belongs anyway. So let's refactor that. Boom, 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 boom. And then we'll just put charlist inside the struct here. It was the vec of hash map of, what did it say? Let's just copy paste that. Oh, that's not going to work now. There, I'll just copy this. Perfect. And then I've got this I gotta fix, this I gotta fix, and charlist vec new. We don't need to do that, but we can say self here, and self here, and then self here. And that should still run the same way. What was it? Why? Let's compare. That looks the same. Okay, good. So we've successfully refactored that. So now we just, for part 2, is just the opposite of this. Instead of B compare A, it's A compare B. And this gives us this value here. Hey! All right, that wasn't too bad. Actually, that was a pretty straightforward puzzle. So all we did here was refactor it into parse, and then A and B have their own collection routines. Git status, git commit -am 2016 day 6 part 2. I don't want to start day 7 because I'm almost out of time. That only took 15 minutes. That wasn't bad. We're blazing through these.